In this video, we're going to make a project for controlling the appliances with the help of Apple Home, Siri, and also with the help of manual switches along with its real-time feedback straight onto our Apple Home app. And trust me, this is the most easiest method to combine Siri or Apple Home with the help of ESP32 without having any Raspberry Pi board, any computer, or any kind of bridge in between. Your ESP32 board will directly talk to the Apple Home and Siri. So this video is for all the iOS users out there. Let's get started. So let's just quickly start with the hardware part of the project. So you'll require these all components for making this project, and you have to connect them all according to the circuit diagram shown in the article, whose link you can find in the description of this video. Now to do a lot of connection, I just designed my own custom PCB for this project and straight away gave its order to GLC PCB. Now you can also order your custom PCBs from GLC PCB by following very simple steps. Just upload the Gerber file of PCB project, select the color masking if you want, and place your order. Now if you select the fastest delivery option, you may get the PCBs delivered at your doorstep within a week. So try ordering your own custom PCBs from GLC PCB to make your project looks neat, less complex, and more sturdy. Now after receiving the PCBs, I just soldered all the components on it, and with this, we are done with the hardware part of the project. Now all the things, all the logic, all the magic is happening with the help of the code used in this project. So let us jump on to Arduino IDE and have a look over the code for this project. So now to make this code work, you need to have a couple of libraries and files to be installed on your Arduino IDE. So let's go to this GitHub repository. Now don't worry, I attached the link for this both repositories onto that same article, so you can just follow that article to land on this particular page. After that, just click on the download zip, and you also need to download the zip file of this particular repository. Okay. After downloading the zip file, just go to the Arduino, click on Sketch, click on Include Library, and go to Add Zip Libraries. Now here, just select those zip libraries that you have downloaded right now, and click on the Choose button. You have to follow this step for both that zip files. After doing that, just go to the files, into examples, and here you will find a new example called Homekit ESP8266. Okay, so here are the example codes that are for your reference purpose to understand how this particular things work. Okay, so I'll open the example 2, which is called as switch. Okay, so here is that example code. So now these example codes are compatible with both ESP8266 and ESP32 boards, so you can upload the same example code onto your Node MCU board as well, and it will work. Okay. So now in all the example codes, we have multiple files. So talking about this particular example code, we have 3 files. That's the main file, myaccessory.c file, and Wi-Fi info.h file. So let's just go through all the files one by one. Talking about Wi-Fi info file, then this file contains the credentials of your Wi-Fi router, okay, as this particular ESP32 board need to get connected with the Wi-Fi router. And let me tell you one more thing, this particular whole complete project is working under local area network connections only. That means the ESP32 board and the iPhone on which the Apple Home and Siri is running should be connected with the same Wi-Fi router, okay, otherwise it won't work, okay. So let's provide that credential of that same Wi-Fi router here. That was it about the Wi-Fi info. It is just responsible for making the connection between the ESP32 board and the Wi-Fi router. Talking about myaccessory.c file, then this is kind of an important file that requires a couple of parameters to be entered. Let me tell you one by one. So first of all, you have to provide the by default state that will be shown onto the Apple home page. Okay, so as we have only one switch, so it shows CHA, that is characteristic switch on. Only one switch is there, so only one variable is declared, and by default we are sending the state as false. Straight after that, we have to write the characteristic name. That means the name that should be assigned to this particular product. Okay, so product name is assigned as switch. Okay, you can assign anything like techiesms switch. Okay, it's just up to you. Straight after that, here is the particular function that that contains a couple of details regarding what this product is all about. Okay, so what kind of details you have to provide? Let me tell you. First of all, you have to provide the ID here. Now as this particular code contains only one switch to be controlled, we have to provide only single ID. But in case you are providing multiple switches, then you have to write ID1 for the second time, ID2, and so on. Okay. Straight after that, you have to write the name of the switch. So earlier it was the name of the product, you can say, and inside one product we may have multiple switches, okay, and those switches name that we have to provide here, okay. So as it has only one switch, so a switch will be good for this particular product. Straight after that, you have to provide the manufacturer name, like the company's name. I will write my name here, like my channel name here. You can write any of the thing. Then the serial number, then the model number, and the firmware revision. So these are kind of details that you have to provide. And if you don't provide, if you keep it by default, then also it's completely fine. This code will work, okay. Straight after that, here is one important thing, which is password. Now what happens is when you kind of pair this particular product with the Apple Home app, it will ask for a password, okay, and that password is mentioned here. You can definitely change this password according to your need, your choice. I'll keep it by default as it is, okay. So that is all about the accessory.c file. Now talk about the main example code, then let me tell you what happens in the main code. So first of all, in the setup part, we are just connecting the Wi-Fi.connect, and after that we are calling a function called as Homekit setup, okay. So let's just jump onto the Homekit setup. Here is the Homekit setup. Here we are just defining the pin switch as output and just turning it on by default, okay. Now pin switch is nothing but the GPIO2 of the ESP32 board on which the built-in LED is attached. So we will be able to visualize this particular working of the project with the help of the blue LED on the ESP32 board, okay. After that, we are just defining that switch that we have configured in the accessories file, okay. In the setup part, of course. Straight after that, in the loop part, we are running a function called as Arduino HomeKit loop. Now this function is responsible for all the tasks performing in the background, like receiving the data from the Apple Home server and controlling the LED on it, okay. So one of that function is defined here, which is CHA, characteristic switch on setter, okay. So whenever we are receiving the data from the Apple Home app, this function will be called, okay. This function will be called. Whatever data is coming from that particular thing will be stored in this particular variable. Straight after that, what we are doing is we are just turning on and off the switch or the pin according to the data received from the Apple Home app, okay, and that will be reflected onto this built-in LED for this example code, okay. And in the loop, we do have one more thing, which is this particular thing will be repeated every 5 seconds. And now what it is doing, it is just printing the data onto the serial monitor. Now what kind of data? The data about how many clients are connected with this particular ESP32 board, and the data about the free heap memory, okay. Heap is kind of a space inside the RAM, okay. So it will show how much free RAM, how much free heap is there into the ESP32 board. So this kind of data will be displayed after every 5 seconds, and that's pretty much it about this example code. Now what I'll do is I'll straight away select the right board, which is the Do It ESP32 DevKit V1, select the right COM port, and straight away hit the upload button, which will upload the code onto my ESP32 board. Okay, so the code is successfully uploaded. I'll open the serial monitor, press the reset button. As you can see, it shows Wi-Fi connected, and it is ready for pairing, okay. So now what I'll do is I'll open up the Apple Home app on my iPhone, okay. Now one thing you need to be sure about is your iPhone should be connected with the same Wi-Fi router on which the ESP32 board is connected with, otherwise it won't work, okay. After that, just click on add accessory, and click on I don't have a code or cannot scan, okay. And as you can see, the switch appear onto this particular dashboard. I'll select switch. I'll select add anyway. It shows uncertified accessory just because this is not an Apple product, okay. So it is not at all certified by Apple, but still we want to add. So we'll click on add anyway. Now it is asking for the password. It will be the same password which is mentioned in the code 1111111. Click on continue. And it is successfully paired, okay. So now it is asking where to store this switch, in which room you want to store. So I'll select bedroom as of now. And if you want to give it a name, you can give it a name. I'll name it as light. Okay, click on continue. I'll select light here, click on continue, click on done, and that's it. As you can see, a light button is added to the dashboard, and I can control this blue LED with the help of this bedroom light, okay. And this is working in reverse order. That means when I turn the switch on, the LED gets turned off, and when I turn off the switch, the LED gets turned on. It's just because the LED shouldered here is it works on reverse logic, okay. So yeah, this thing is working, and this thing can also be controlled with the help of Siri. And let me show you. Turn on bedroom light. As you can see, the bedroom light turned on. So yeah, our project is perfectly working with the Apple Home app with the Siri. Okay, so now this was just an example code, or this was just a demo code, but we are not here for controlling just LED. We are here to control the actual big appliances along with the Siri, along with the manual switches. Okay, so let me just take you through that code as well. Okay, so what I did is I just took the help of that example code and created my own new code to make it compatible with 4 switches, 4 appliances, and here is the code which says internet and manual using Apple Home Siri. Okay, so here also we have 3 different files, so let me just go through each file one by one. Wi-Fi.info file is exactly the same. I haven't made any change in this particular file, so I'll skip this and go directly to my accessory.c file. Now this is kind of file in which I have made a couple of changes. Let me guide you with that changes. So first of all, here I have declared 4 different variables like switch 1 on, switch 2 on, switch 3 on, and switch 4 on, and they've provided by default state as false to all 4 variables. Okay. Straight after that, here I have changed the product name to 4 channel internet and manual. As I told, this is a product name which you can choose and you can provide according to your choice. Straight after that, here I have copied and pasted this much line of code for 4 different times for 4 different switches. Okay, now what changes you have to make in each of the function, let me tell you. First of all, you have to change the ID. So here it is, for switch 1 the ID is 1, for 2 it is 2, 3 and 4, so on. After that, you have to change the name of the particular switch provided in a particular product. Okay, so product name is this. Inside that we have switch 1, inside that we have switch 2, switch 3 and switch 4 and so on. Okay, after that, you can keep these names same for all the 4 switches, doesn't matter. Now one thing which you have to take care is you have to change this particular variable name here. Okay, so as it was written as CHS switch 1 on, so I provided CHS switch 1 on. For switch 2 the name is this, which is provided here. For switch 3 it will be switch 3 on, and for switch 4 it will be switch 4 on. Okay, so that thing you have to take care while changing this code. Okay, straight after that, here I have put the password again the same, like the by default password I have maintained here. Okay, if you want to change, you can change this, of course. Okay, that's it about the myaccessory.c file. Now let us jump on to the main code. Okay, main file. So here, first of all, I have declared all the switches and the relay pins here according to the circuit diagram. After that, here are the couple of variables necessary to be declared for controlling the appliances with the help of manual switches. Straight after that, in the setup part, there is no changes. Everything is pretty much same or exactly the same. This void loop is exactly the same. Now the changes made are, I have defined this 4 variables for switch 2, switch 3, switch 4. Okay, that's necessary because we have 4 switches here. After that, earlier we were having only this single function because we want to control only single pin of the ESP32 board. But this time, as we want to control 4, I just copied and pasted this function for 4 times. And the changes I made is I just renamed the switch as switch 1, switch 2, switch 3 and switch 4. Similarly, I am sending the data to relay 1, relay 2, relay 3 and relay 4. So that's the changes which I made here in the particular code. So one thing you have to remember is wherever switch is written, you just need to copy and paste that switch and rename it as switch 1, switch 2, switch 4 up to whatever number of appliances you have connected. Okay, so that's kind of a simple hack, you can say, like what changes you have to make. Straight after that, into the setup part, I just declared input and output, nothing new. Here I have declared 4 kind of setup for 4 kind of switches. And jumping to the loop, here the Arduino Homekit loop is pretty much the same or exactly the same as previously we have seen, but the only new function added is this switch feedback function. Okay, so this is a function created by me, which is this. Now this function is responsible for controlling the appliances with the help of manual switches, as well as sending the real-time feedback to the Apple Home app. Okay, so the feedback that we are sending is with the help of the single line which is about notify. So we are notifying the Apple Home app whether the switch is on or off. Okay, so yeah, that was all about how I converted that example code into the internet and manual 4-channel home automation project. So let's upload it, but wait, this won't work if I upload it straight away. Here is one really great catch, you can say. Okay, so what happens is, as soon as we uploaded the example code, or let's just take example that whenever you upload this Arduino HomeKit example code onto your ESP based board for the very first time, it will store a couple of properties inside its memory and it will be stayed inside it forever, even if you upload the new code. So what will happen is, even if I upload this particular code, ESP32 board won't be ready for pairing it to the iPhone. Okay, so once it is paired, it won't be able to pair again with any other device, or even with the same device it won't be able to pair again, okay, because of that data stored in it. Okay, so one thing we have to do is we have to erase that particular data before uploading a new code so that it can pair again with the new phone or with the same phone. Okay, so for doing that, this particular team has already provided one function called as Homekit storage reset function. Okay, and they have mentioned here as to erase all the memory, you have to uncomment this particular line and upload the code and it will be erased. Okay, but what I experience, or what all people experience on the what you can say community people experience, is that whenever we uncomment this line and upload the code onto the board, the code is not working. The board is continuously getting crashed. It is automatically getting resets all the time. Okay, it is not at all working. Okay, and we don't have any solution for that. But hey, I came up with a very, we can say, smart or simple solution. What I did is I took the help of the ESP tool. Okay, let me open up the terminal. I took the help of the ESP tool, and by just following this particular simple line, I am able to completely erase the flash memory of the ESP32 board. Okay, so you have to just write esptool.py. Then you have to provide a chip name, which is ESP32. Then you have to provide the port, which is this, and just write erase flash. And when I just run this command and press and hold the boot button, I'm able to completely erase the memory of this particular ESP32 board. Okay, so this is the process for Mac system or Mac laptops. But if you're using Windows laptop, the process is different. Now, if you don't know how to erase this flash memory using ESP tool, and if you want me to make a video, a dedicated video, like a short but useful video for this, then do let me know in the comments. So what I'll do is I'll pin one comment under the comment section. Any of you who want me to create a video about how to erase flash memory of the ESP board can reply to that comment, and as I get multiple comments reply on that particular pinned comment, I'll definitely try to make the video for you people. Okay, so it's just up to you. If you want it, then I will make it. So if I get a majority of requests, then I'll go forward to make that video. Okay, so now the chip is successfully erased. Now if I open the serial monitor, as you can see, I'm getting this particular reset thing onto the serial monitor that shows that this has nothing inside its flash memory. It's completely erased. Okay, now this board is ready to be programmed again, and if I upload this code, this time it will work. Okay, so let's just test it out. Okay, so the code is successfully uploaded. I'll open the serial monitor, press the reset button. As you can see, it shows Wi-Fi connecting, got connected, and it is ready for pairing. Okay, so I'll again open up my smartphone and open the My Home app onto my iPhone. Okay, I'll click on the add button, click on add accessory, click on I don't have a code, and here as you can see the switch appeared. I'll select the switch, add anyway, code is 1111111, click on continue, and it got successfully paired. Okay, so I'll create a new room for this and name it as my studio. Okay, click on continue. I'll rename it as switch. Okay, switch 1 is okay. Okay, click on continue. As it is a switch, I'll click on continue again. Okay, switch 1 is successfully added. Similarly for switch 2, continue. Similarly for switch 3, again continue, and similarly for switch 4, again continue. That's it. We have successfully added all the 4 switches onto my home application, and if I go to the rooms and go to my studio, as you can see all the 4 switches appeared here, and I am able to send the data from the app to the ESP32 board, which is reflected onto the serial monitor. So which this reveals that this complete project is successfully working. Okay, so now what I'll do is, as I already installed this particular project, the hardware, into one of the switchboard of my studio, I'll straight away insert this ESP32 board onto the PCB, and let's just see this project working in action. So as you can see, I'm able to control the appliances with the help of my home application on my iPhone. Now let's just test it with the help of Siri. Turn off switch 4. Okay, so it is also working with the help of Siri Smart Assistant. Now let's just test with the help of the manual switches. Okay, so it is working with the manual switches, and we are also getting its real-time feedback onto the My Home app. Now here one more thing we can do with the help of Siri, and that is to ask the live status of the particular appliances. Let me show you. What's the status of switch 4?
Your switch 4 is off.
So yeah, with this we can see that our project is successfully working. Now I hope you enjoyed this video and got to learn something new from it. Now if it is so, consider liking this video. Do consider liking this video. That really motivates us to make more such unique projects for you people out there. And also comment below if you really want me to make that flash memory erasing video for ESP boards. Do let me know, and also let me know what more projects you want me to make into the comment section of the video, and me and my team will definitely try to make this project just for you people. That being said, ending this video here and now. Just wait for my next video to explore, learn, share with me, techiesms.